sorry about that. I was kind of interrupted by one of my kids. There was a little bit of an issue, but we're all good now. And I left off by talking about the arterioles and how they vasoconstrict and vasodilate. And then they go to this, and this is called the capillary. You can see that the capillary, right? You're going to see the blood flow sort of decrease even more. So at the capillary, you're going to get a decrease, a further decrease in blood pressure. Okay? And the capillary is really important because at the capillary level, okay, what I'm drawing here are cells. So you guys have about 65 trillion cells in your body that make you who you are. And each one of these cells are hungry, right? And each one of these cells need oxygen, right? Because these cells undergo cellular respiration. So whenever I draw red, I'm drawing blood that is O2 rich. So all this red blood is called oxygenated blood. Okay, so it's called oxygenated blood. It's in the PowerPoints, right? And what you're doing is this oxygenated blood diffuses, okay, into the cell. So all this oxygen is diffusing into the cell because the cell needs it in order to undergo respiration. And what else is happening? Well, you're also going to see food diffusing to the cell. So you're going to see all of this. So I'll draw it. You're going to see food. So here's the food. That's also going right to the cell. You know, so the capillary is really important because that's where diffusion occurs. So diffusion only occurs at the capillary. And the reason why it only occurs at the capillary is because the capillary is one cell thick. So it's easy to break, right? So imagine if I was to draw the capillary, okay, which I will right here. The capillary is very, very thin walled, okay? So this is the capillary. And it's made up of a single cell layer. So these are all cells, right? And because it's only one cell thick, like there's no muscle that surrounds it. There's no elastic layer. It's just a single cell layer. It can break really easily. So like if you bruise, you've probably broken your capillaries, okay? That's what you did. You broke your capillaries, and that is all the blood underneath your skin, you know, that happens because you've broken that, okay? And they will eventually repair themselves, but there you go, that's the capillary, okay? And so the capillary is really important because not only do you give oxygen to your cells, what is returned is CO2. So now you have all this CO2 being returned to your blood, and the CO2, right, is going to collect into this first, okay, is this venule. Okay, so it's going to collect into this venule over here, okay, and then it goes to the vein over here, okay, so this is the vein, and the vein, the definition of a vein is that all veins lead to the heart, okay, so all the blood in the veins go to the heart. So remember the heart is way up here, so now the blood has to go up, and the blood has to go back to the heart, right? And it's going to go back into the right side of the heart. But like, how do you make the blood go up? It has to go up against gravity. Well, because it has to go up against gravity, your veins contain valves. And so we're going to draw the valves in here like this, okay? So here is the valve in your vein, right? And what ends up happening, so here's the valve, is you guys have muscles that squeeze. So you're going to squeeze. These guys are skeletal muscles. So these muscles are actually attached to your bone, right? And they're going to squeeze the vein. So they're going to put pressure and they're going to squeeze the vein. And when these skeletal muscles squeeze the vein, it then, right, when you squeeze the vein like that, it causes the blood to move forward, right? It causes these valves to open. So now the valve is open, and then the blood pushes up, okay? You're going to see these skeletal muscles all throughout the vein like that. Okay? And you're going to see, like, when you squeeze those muscles, right? You're going to see the valve open and you're going to see the blood moving up. Okay? So you squeeze the vein, the valve opens, blood moves up. When this valve is open at the top, this valve has to stay closed on the bottom. You never want blood to go back down. You always want to move the blood up. Squeeze the vein, push the blood up. This goes up and this, right? Because this valve is open and that valve stays closed. Now, if you were to look at the structure of a vein, you're going to see that veins, okay, if I was to draw what a vein looked like, you're going to see that veins are very thin they have this thin, smooth muscle wall. And they're also elastic. And the reason why this vein is so thin is because the vein is under zero pressure. There's no pressure in the vein. It's at zero. You got to generate the pressure, right? You got to, like, so you were at the highest pressure, right? The heart squeezed, highest pressure in the arteries, all arteries lead away from the heart. Then the blood pressure, right? Lowered because you got the arterial and the blood went into the arterial. And so you lost pressure at the arterial. You lost even more pressure at the capillary, right? As you branched even more and you gave oxygen and sugar to your cells, and the cells returned the CO2, right? And then you have the CO2, you want to bring it back to the heart, right? All veins carry blood to the heart. And in order to do that, you have these skeletal muscles that squeeze the vein. This valve opens, this valve should stay shut. You know, if this valve didn't stay shut and this valve stayed open, you would get varicose veins, which are the bulges in your veins because these valves don't work properly. But anyways, so these veins push the blood back to your heart, right? And the veins are under such low pressure because you've lost all the pressure, right? You know, highest pressure artery, you lost pressure when you went to the arterioles, you lost even more pressure when you went to the capillary. By the time you get to the vein, you're at zero pressure, and the walls in the vein are the thinnest, okay? You have the thinnest walls in the vein. Okay, so that's my lesson on blood vessels. I hope that helped. And I will try to post the last lesson on blood tomorrow. I hope you guys are doing well, and I hope that was very helpful to you, okay? You guys take care. Bye-bye.